Hi guys, BuildZoid here, and today we're going to be taking a look at the RTX 2080 Ti Lightning from MSI. So it is an MSI's take on an extreme overclocking card. It's not as nice as some of the past Lightnings. It's nowhere near as, like, the thing is, this thing is kind of like an extreme overclocking card where they basically went through like the bare minimum requirements for extreme overclocking and just started adding check marks in boxes. And let me point that out. So, first up, we have the 888 pins. I think for 2080 Ti's on liquid nitrogen, 888 pins, great design decision. You do need this because 2080 Ti's chug power. Okay, they absolutely chug power. You do want your 888 pins. This is a reasonable design decision. It's like 980 Ti's. 980 Ti's also pulled so much power that it didn't make sense to try power them with just 2 8 pins. 780 Ti's were the same thing. GTX 480s, GTX 580s. Like, there's a lot of past cards where it made sense to make extreme overclocking versions with a lot of power connectors. 1080 Ti's weren't, didn't need that. But 2080 Ti's, I do think 888 pins is not, so, it's not pointless like on some of the 1080 Ti's it was. So they do have the 888 pin power connectors, right? So that's one feature checked off because you do need to be able to deliver a ton of power when you're on liquid nitrogen. Then we have some voltage monitoring points because as far as I know, software voltage monitoring on NVIDIA cards is completely terrible. It's a lot of things, but like accurate or actually monitoring the voltage is not one of the things it does. So you do need voltage read points if you actually want to know what the actual physical voltage going into the core is and not what the software is telling the voltage controller to put out. Especially considering that as far as I know, when you start using the various extreme overclocking utilities for 20 series cards, it straight up breaks the voltage monitor, like it breaks the voltage monitoring even more so. So at that point, you don't even because at that point, you're basically, as far as I know, the way it's supposed to work is, you basically tell the voltage controller to do its thing and ignore what the driver is telling it to do, which is what you want because the driver is stupid and imposes a very low voltage limitations. So essentially, your software voltage reading is just complete garbage at that point, and you do need a physical method of monitoring your voltage. So these are nice to have, and they're a requirement. So there, we can check that off the list of things an extreme overclocking 20 series card requires. So we got that. Then we have voltage controllers that aren't the UP9512 because the UP9512 is dumb. So instead we have the MP2888 and the MP2884, which aren't dumb. These are like proper high-end digital voltage controllers where you can control things digitally and also monitor things digitally, except that feature has to be disabled or NVIDIA would stop giving you GPU cores. Like, seriously, that's one of the big issues with building any extreme overclocking card for NVIDIA GPUs is you need to get your GPU design approved by NVIDIA, and NVIDIA is not going to approve it if it has working, if you have like proper physical voltage monitoring and voltage control. So yeah, so essentially, like, if you have a Galax Hall of Fame card, you have to go through like this pretty fiddly process to actually get access to the proper extreme overclocking tools, and I assume the Lightning is going to be the exact same thing, where unless you know somebody that works at MSI, you don't have a chance of actually getting voltage control on this thing, because NVIDIA would, blow a fuse if MSI did that. So, we got our voltage controllers that we need, and then on the back of the card, and I broke GIMP, which keeps happening, we have the dual BIOS switch. Yay! So you have LN2 mode and you have original. And the BIOS that this ships with is not a proper LN2 BIOS. There's definitely a, special engineering sample, unreleased, non-public BIOS that actually fully unlocks the card. But yeah, like, as I said, NVIDIA would blow a fuse if MSI was shipping cards with that BIOS on it. With that BIOS on them, so yeah, you're not going to see that, unfortunately. Anyway, let's go back to the front of the card. Oops. So, and I forgot something. So before we keep rolling with this video, the PCB pictures are, of course, from Tech Power Up. And I should have put that at the start of the video, but I forgot. So yeah, these are from Tech Power Up's review of the RTX 2080 Ti. Huge thanks to them for, uploading high-res PCB pictures like this one right here. Anyway, back. Oh, and I'll leave a link to their review down in the description. Anyway, back to the card here. So, you know, we have our bare minimum requirements for an LN2 overclocking card. We have the triple 8 pins, we have some voltage monitoring capability, we have proper voltage controllers, and we have dual BIOS. Great. So we've checked those features off. And then we get to the VRM. And this is where I say this is like a bare minimum extreme overclocking card. Because this VRM is exactly, well, it's not special. It doesn't really do anything we've never seen before. In fact, if you've seen an FTW3, you've seen most of what this VRM is, because that's basically what it is. So, as usual, we have a 3-phase memory VRM up top, 1, 2, 3, right? So that's the same as always. And then we get our vCore block 1 and vCore block 2 on either side of the GPU core, which I've discussed the benefits in benefits of doing this in a past video a while ago. But anyway, so then we have vCore block number 2 over there. In terms of actual phase count, MSI has the MP2888 configured in 8-phase mode, which is kind of interesting because as far as I know, this chip is supposed to support 10-phase mode max. So I'm not sure why MSI decided that they don't want to go with 10-phase mode. It might just be due to the added complexity of implementing that. And we know that they're not running this thing in 10-phase mode because we have current monitoring circuit 1, current monitoring circuit 2, current monitoring circuit 3, 4, 5, 6, 7, 8. And for comparison, the Strix RTX 2080 Ti, which actually implements the MP2888 as a 10-phase, has 10 of these circuits instead, not 8. So, yeah, that's kind of how I know that this is an 8-phase. And so we have the usual massive, you know, RTX 2080 Ti 8-phase that we've seen, you know, we've never seen before, except we have, because, like, the FTW3 does this, the Gigabyte Extreme card does this, I'm pretty sure the Zotac card does this. Like, I can't really think of an RTX 2080 Ti that like, doesn't do this, other than, like, the Strix. The Strix has a 10-phase. That's pretty cool. And the Hall of Fame has a 10-phase. And I assume the EVGA card will also have the MP2888 running in a 10-phase configuration. But, anyway, so here we have the, you know, massive 8-phase, and what's going on with the massive 8-phase is basically, the card doesn't use doublers, so they take one PWM signal and they shove it into 2 power stages at the same time. So essentially you get like a block that turns on, you know, your 2 power stages turn on and off at the same time. And you basically get one giant phase instead of, you know, 2 separate ones that are like interleaved. The downsides to this is that you potentially have slightly more output ripple. You can clean up output ripple with higher switching frequency or better output filtering, or there's a million and one ways to deal with all kinds of issues, right? You can go for higher inductance, lower inductance if you want faster transient response. You can do all kinds of tweaks to your VRM to get, you know, different kinds of performance depending on what you're aiming for. But what we're seeing here is very standard. I mean, I'm pretty sure these are actually the same inductance spec chokes as like a reference RTX 2080 Ti. So MSI is really not changing much here, including the 8-phase. So that's what we have. What we have going on here. And so you basically get blocks like, well, I'm not sure if they're specifically like that, because like there's nothing stopping them from having like this power stage grouped up with this power stage and then this one with this one, and so there's nothing really stopping them from doing something like that. It would just be even more unnecessarily complicated potentially, so it just makes more sense to me that they would just group them up in groups of 2. And for illustration purposes, you know, we can go with that as well. So you get 1, 2, 3, 4, 5 phases on this side, and then you get your phases 6, 7, 8 on this side, right? 6, 7, 8. And that's very likely exactly how it's wired, because doing anything like trying to group them up differently would just be unnecessarily more difficult to do, and wouldn't necessarily provide any benefits. So, at least I don't think it should provide any benefits. Anyway, so yeah, giant 8-phase, and then we have the most bog standard power stages of any RTX 2080 Ti ever. Say it with me, everybody. FDMF 3170, cheapest 70 amp smart power stage to be currently available on the market, at least as far as I'm aware. These things are so cheap. I asked motherboard vendors why they don't use them more, like instead of the usual international rectifier suspects, right? And the answer was basically everybody's worried that these will run out because of the demand for NVIDIA GPUs. Basically, if something gets used on NVIDIA GPUs, you don't want to use it on anything else because you never know when NVIDIA might buy all of the stock. But anyway, so 3170s, 70 amp smart power stage. They're smart because they integrate current monitoring, they have over temperature protection, and they have over current protection. Over current protection kicks in at 80 amps, over temperature protection kicks in at 140 degrees Celsius, and the integrated current monitoring basically means that instead of having a rather normally you had to have like a rather elaborate system for current monitoring. If you weren't running 2 power stages in parallel and just had 1 power stage per phase, you could basically just run a wire like that for current monitoring, and that's all you have to do, which is really, really cool. All right, massively simplifies your PCB design, and that's why they're called smart, because they do a lot of the stuff that the voltage controller used to have to do. Well, it's now done here, and it's just reported back to the voltage controller. So that's why these are smart power stages and not dumb power stages. Anyway, well, not regular power stages. Anyway, the end result of this is well, we've seen the end result before. We've probably seen it at least 3 times. We've got 16 FDMF 3170s in a massive 8-phase. So running at 500 kilohertz switching frequency, 1.8 volts output, because that's what these are spec'd for, because they're meant for powering Intel CPUs with integrated voltage regulators, not NVIDIA GPUs, and then scaled down to 1.2 volts based off of data sheets for other 70 amp smart power stages. Let's go through our current, efficiency for a given current level. And fun fact, I actually copy-pasted all of the figures for the efficiency here from the EVGA FTW3 PCB breakdown I did for Gamers Nexus, because it's the same power stages in the same phase, like in the same configuration. And we're not considering like inductor losses, capacitor losses, and those kinds of things, because they're they're minor compared to what your power stage burns up. So anyway, 200 amps output for 1.8 volts, you're going to be looking at about 20 watts of heat. 1.2 volts, you're going to be looking at about 17 watts of heat. Essentially, this VRM is so huge and so very powerful that you don't need a heatsink on it, right? at like 200 amps output. So yeah, that's pretty neat. You don't need to worry, too much about cooling this. And I think like the nice thing with these massive, I've thought about it. Is there any benefit to having like these ridiculous power VRMs on these cards? And there is a benefit. Right, let's say you want to run this card on a you want to run it on a water, you want to run it with water cooling, and you can't find a full cover block, right? Well, you don't have to have a full cover block, because the full cover block, all it really does is cool it cools the memory and it cools the VRM. Well, I got news for you. If you zip tie a fan over here and you zip tie a fan over there, you're probably going to be perfectly fine on memory and VRM temperatures, because the air is just going to get sort of blasted all over the PCB, and the whole thing acts like a massive heatsink anyway. So not a great heatsink, but a pretty, given enough airflow, anything can be a pretty good heatsink. At least up until the point that you have so much airflow that there's like friction from the air producing more heat than what you're removing. But I don't think fans would necessarily be able to do that. Anyway, well, you'd need a hell of a fan to achieve that effect. Anyway, moving on to higher current levels. So 200 amps, that's what we're looking for. That's like a stock 2080 Ti. Going up 300 amps, this is like water cooling range, and even 400 amps, you should be able to hit that on water cooling range. And if you're wondering what that actually equates to, well, the card runs on like 1.0x volts. Right, in this current range. So if your full board power is around 450 watts or something like that, you're pushing well over 300 amps into the core, because, I mean, the VRM is not losing a whole bunch of power, right? Because for 300 amps, you're only looking at about 30 watts of heat produced for the 1.8 volts output, and only about 26 watts of heat produced for 1.2 volts output, right? So you have some 26 watts of power loss on the VRM. There's the memory system, which combined probably doesn't pull much more than 40 watts at most. if even that. It very likely pulls less than that, but you know, if you have the card pulling 400 watts or at least hitting the power limit on a 400 watt BIOS, well, you're pushing over 300 amps pretty easily because the cards run on like 1 volt. So you do the math. 1 times 300 watts, right? And then plus VRM power loss, plus memory power, plus minor rails, which they're going to be under like 10 watts each. Then maybe add your fans if you still have those hooked up to the card, you know. So yeah, this is totally achievable on ambient cooling. This current range is. Anyway, so 400 amps, you're going to be looking at about 45 watts of heat, and then about 39 watts of heat for 1.2 volts. So, you know, pretty standard, like high-end RTX 2080 Ti's all come with VRMs that do roughly this. This is not the most efficient one, mostly because the FDMF 3170 is a little bit weaker than some of the other available 70 amp smart power stages. Anyway, keep going up. We hit the 500 amp range, which I would assume is what you would hit with, say, like dry ice cooling. And at that point, you're going to be looking at about maybe 60 watts to 52 watts of VRM heat output, and also 500 amps on dry ice. Man, that's going to run so warm. Like, I would not be surprised if you ran this on dry ice, and by the end of the benchmark, you were hitting like minus 20. Like, I would be super unsurprised if that actually happened, because that is a lot of heat. Also, at dry ice temperatures, you would start actually raising your core voltage, so it would no longer be like 1.x times 500, it'd be like maybe 1.2, right? So you'd have maybe like 600 watts of actual GPU heat output, which is a lot of heat. And also why you need triple 8 pins by the time you hit liquid nitrogen, right? Which starts, which as far as I assume liquid nitrogen current pulls start at around the past the 500 amp range, well into like the 600, 700 amp range. And at 600 amps, you'd be looking at about 82 watts of heat output, or about 70 watts if it's outputting only 1.2 volts. Though at this point, you're going to start raising the core voltage very likely even past 1.2 volts, so you're going to be trending towards that 82 watts, right? So we're going upwards, and then 700 amps output, you're going to be looking at about 106 for 1.8 volts, and about 92 for 1.2 volts. So probably around 100 at voltages that you would need to hit these kinds of current figures. So yeah, VRM, you know, is a bog standard high-end RTX 2080 Ti VRM. I hate to say it, but it's true. I mean, MSI hasn't even done anything particularly elaborate with the output filtering section on this thing, right? And if you're wondering what I mean by elaborate with the output filtering section, I mean, look at this, right? And like, so we have our bulk, okay, wait, wrong layer. So we have our bulk capacitance, right? Then we have our smaller bulk capacitance. So these are going to be like, these are at best going to be like 5 ESR. At best, these are going to be like 3 ESR. And your ESL for this packaging is better than your ESL for that packaging. These are multi-layer ceramics, which just run circles around both of these on both ESR and ESL. So these are, again, you know, less capacitance, but better frequency response yet again. And then we got the really little ones. For even, you know, like, this is a nice elaborate output filtering setup, right? We have all kinds of capacitors mixed together so that they can compensate for each other's weaknesses. And then there's MSI's approach to it. And MSI's approach is just bog standard aluminum, 820 microfarad aluminum polymers, and a couple multi-layer ceramics. And it doesn't even get better on the back of the board. In fact, on the back of the board, we can see evidence of cutting costs because these are missing, right? Like, where's this guy? Oh, and what about you? And you? And just all of these guys. And this, right? So, yeah, I'm really not impressed with what MSI has done in terms of the VRM. Just, like, the VRM itself is not bad, right? It's plenty efficient, but it's not special, right? Which is something that, at least personally, when I look at a Lightning, I want a special, extreme overclocking card. I don't want a FTW3 with like LN2 features bolted on, because that's kind of what this basically is, right? It's a pretty standard high-end RTX 2080 Ti with LN2 features bolted on top of that. And they've not really gone any further than that. And I assume it's because of stupid gimmicks like the LCD, because LCDs are pretty expensive. And then you need like an LCD controller. So, like capacitors are cheap, right? Like this, this cap right here, probably 10 cents. If these are like a really expensive Panasonic aluminum polymer, really low ESR, they might be $1 a piece, right? And it's just like, I would happily trade that LCD thing for a better output filtering section. And the same goes for the memory. Like MSI just, like I'm sure this does a fine job at ambient on ambient cooling, right? Like on ambient cooling, you're not going to see a difference between this and other cards, but on LN2, like I feel like I would prefer to have something that looks like the Galax card rather than this, right? Which is just like, yeah. I mean, it's perfectly possible that all of the work that Galax put into their output filtering section doesn't actually have any, real world impacts, but it's still better, right? Like just on paper, that is theoretically better. And then Galax doesn't like, and the thing is like the VRM itself between the two cards, like this one's slightly, if I remember correctly, this one's slightly less efficient than what you get on the Hall of Fame. Not that that's a big deal, right? Power wise, like they're both fine. They can both push a card on LN2 just fine. It's just that this one, it's kind of doing the bare minimum as far as I'm concerned. So yeah, not a huge fan of that. Though I am glad that MSI hasn't completely scrapped the Lightning. Like compared to what Asus did with the Matrix, I am happy that we have, like this is a Lightning, and at least it has the 888 pins and the voltage read points and the dual BIOS, right? This is still way better than what Asus did with the Matrix card, where they basically took a Strix and put an AIO in it, when historically the Matrix cards were, the Matrix cards were the Hall of Fame for Asus. They were the Kingpin edition, except from Asus. And now we have the Matrix card, and it's like, what's so special about it? And it's like, oh yeah, we bolted an AIO to it, and I'm like, I want my LN2 cards back. Not that I would buy them, mind you. I think RTX 2080 Ti's are incredibly overpriced in general. So, I shouldn't be complaining, because at the end of the day, these things really aren't targeted at me as a consumer. I'm not going to buy them just based on the fact that they're too expensive. But I'm still sad that, like we're seeing these these names used to mean something. And over time, they mean less and less, and I'm really... Like, MSI still, like, this is still far above what, like, Asus did with the Matrix. I think Asus, with what they did with the Matrix name, is they've pretty much dragged it through the dirt in, like, one step. But, I'm still not a huge fan of the direction the Lightning series is going in. Anyway, memory VRM, bog standard 3-phase, well, other than the MP2884, bog standard 3-phase memory VRM that we've seen on every other RTX 2080 Ti ever. So that translates that it puts out 20 amps at about 2 watts of heat, 30 amps at about 3 watts of heat, and 40 amps at about 3.5 watts of heat. Yay! So that's kind of that. That's your 3-phase memory power. Now, admittedly, MSI does have like full voltage control for all of their minor rails as well, I assume. So like your PEX rail and also your 1.8 volts will be monitored. And yeah, we can actually see that because we have 1.8 volts VPLL. So that's what MSI likes to call PEX, I guess. And then we have VMEM and VGPU. So we can tell that, you have all of the voltage control you want. It's just that they've not really done much of anything with the VRM that would make me impressed here. But hey, maybe it'll work out for MSI, except I kind of like right now there's a Galax Hall of Fame, 2080 Ti that did like 2.67 gigahertz for 3D Mark Firestrike Extreme. The highest clock Lightning I've seen so far for Firestrike Extreme has been at like 2,505 megahertz, which like that's a lot. Right, that's an impressive frequency to hit, but I'm not sure. Like, I'd really like to see MSI actually top the charts. They used to, right? There was a time when like R9 290X Lightning, it was just like that was the best R9 290X ever. for LN2 overclocking. And then you had like the I think it was the 680 Lightning and like 580 Lightning and 7970 Lightning. Actually, lots of the AMD MSI cards were like absolutely like killer in extreme overclocking. And then more recently, it's just kind of like, oh, it's the top of the leaderboard. It's either Hall of Fame or it's a Kingpin edition, right? I mean, the Matrix series is basically canceled, and the Lightning cards are they're still here, but I think on their last legs. So yeah, and you know. Well, I'd like to see, more variety in the top of the leaderboard, but at the same time, I completely understand that, making a card like the Hall of Fame is really expensive, and then who do you sell it to, right? Because for ambient cooling, I don't think it'll make any difference, regardless of, like, what Galax has done compared to what MSI has done. I don't think on ambient you'll see any difference at all. And there, I think, ultimately, MSI will have the advantage of actually being available, whereas the Hall of Fame cards are kind of a pain to get your hands on. So, yeah, that's kind of that. So, before we end this, thanks to Tech Power Up for the high resolution PCB pictures. And so that's it for the video. So like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, and there's also Teespring merch. You can find links to both down in the description below. Patrons get access to, well, you basically get updates on what's going on in the background through the Patreon Discord mostly. So yeah, also sometimes you get bonus videos, because the videos are so bad that I don't feel like uploading them to the to the main channel. Anyway, that is it for the video. Thanks for watching, and goodbye.